triangle is cut from the corner of a rectangle, and we create a pentagon with side lengths as shown. So let's just think about this, like the 20, that's the longest length. Now, in theory, I could create a pentagon by taking a cut here, getting rid of all of this, and I could make 20 then the longest side. Then this one would be 15, or one of the sides would be 15. Let's just make it the bottom one. And then surely that would have to be 13, like the second longest side, because these two are definitely going to be smaller. Now, if I made this one 8 and this one down here 10, then that would have to be 3, that bit that I've cut off, and that would have to be 7, and there's no way I can do 3 squared plus 7 squared to get 20 squared. So from the lengths shown, we can sort of convince ourselves that no, that can't be 20. That it must be the side of the rectangle is 20, and maybe it looks a little bit more like this. And we'll also go with that one being 15. I mean, we don't know that for sure. Like maybe that one could be 15 and that one could be 13. But you kind of just got to try things out from here. All right, now how to work out the length of the other sides? Well, we do have a right angle triangle here. So we can think about Pythagorean triples, work out what that hypotenuse is. So our smallest primitive Pythagorean triple is 3, 4, 5. That means they don't have any common factors when I say primitive. But there's no 5 in there, so I can rule that one out. But I could multiply it by 2, for example, 6, 8, 10. So maybe this one could be 10. But then I'd need, for example, or one of these to be 6 or 8. So if that was 6, I'd need 14 there, which I don't have. And if it was 8, I'd need to have 12. So actually, I can rule out it being 10. But we kind of got to use this sort of approach to get there. I could times the 3, 4, 5 by 3 to give me 9, 12, 15. I can just times by a scalar because all I'm doing is taking my 3, 4, 5 triangle and I'm enlarging it by a scale factor 2 or by 3. So I just double the sides. I'm still going to create a Pythagorean triple. That's what I'm doing here. Well, okay, we've got a 15 here. So let's just imagine for a moment this one was 15. Okay, now I can actually tell ourselves for sure whether it is. Now I'd need me either if I'd need a maybe a, sorry, a 12 up here, and then that one could be 8. Okay, it's good so far. But then I'd need that one to be 9, and that one would have to be 11. It would also have to be 20 in length. So I can rule that one out as well. That one can't be 15. So we're back to that length being 15. Okay. All right, kind of exhausted this because the next one up would be too big. Now this is where I recommend that you learn these Pythagorean triples. So the 3, 4, 5 is like the first one that you learn about in Pythagoras. These ones are a little bit harder to remember, but you might have kind of recognized them by using Pythagoras a lot. I'd say try and learn them because I've seen this one come up twice now in senior math challenges, including in this question. And maybe on other questions, you could use applications of the others. So yeah, I just think, I mean, there's an infinite number of primitive Pythagorean triples, which is what these all are. But just go with the first 4. Just see if you can like be able to like just pull them out when you need to. So let's see if the 5, 12, 13 one will work. If we make this one 13, right, I'm going to need 12. Okay, if I put a 12 there, I'd need a 3 there. That doesn't work. But what if I put a 12 there, then I put an 8 there, that's okay. And then if I make that one 5, that one would be 10. And this all checks out. This must be, I mean, okay, we haven't eliminated all the other possibilities, but I think we have actually, because yeah, we can't use this one, we can't use this one. So to create such a triple, yeah, this must be the pentagon. Okay, I don't need these lengths now. That was just for the Pythagorean triple. These are the lengths of my pentagon. Actually, I do need the lengths because if I'm finding the area, it's going to be 15 times 20, and then I'm going to minus this triangle, a half times 5 times 12. This one's 300, and then it's 5 times 6 300 minus 30, which gives us an answer of 270. So the message here is definitely learn first few primitive Pythagorean triples, be able to use scalar multiples of them as well. Questions like this can come along that require it.